Welcome to our lesson on section 3.5, Derivatives of Trigonometric Functions. In case it hasn't come up in class yet, it's important for you to know that in this course, angle measures are assumed to be in radians unless otherwise noted. I'll be graphing on my calculator for part of this lesson, so you may want to pause and find your calculator before continuing. In this lesson, we'll look at the derivative formulas for all 6 trig functions. Let's start by using a calculator to graph y equals sine of x and its derivative in the same window. If you're following along on your calculator, start by checking to make sure your calculator is in radian mode. You can enter sine of x as the first function in your y equals screen. Then move the cursor down to y2. To find the numerical derivative function on your calculator, press second 0 to open the catalog, and then the log key to skip to the ends in the catalog. Select n-deriv, then type sine parentheses x, comma x as shown on my screen. Note that if you have the new TI-84 operating system, when you press n-deriv, you'll actually get something that looks like a derivative. Just enter an x in the box underneath dy to calculate dy dx. Type the sine of x in the parentheses, and enter an x in the last box to calculate the derivative at all different values of x. To graph, use Zoom 7. This gives you a preset window for trig functions. I've enlarged and color-coded my graphs here on the screen. The red one is y equals sine of x, and the blue one is its derivative. What function does the blue graph look like to you? Well, it looks just like the sine graph, but it appears that it's been shifted to the left by pi over 2. If you guessed y equals cosine of x, you were right. So based on the graph, we might conjecture that the derivative of sine of x is cosine x. Here's the proof. This first line shows the derivative of sine of x using the limit definition of the derivative. Then we can apply a trig sum formula to the sine of x plus h to get sine x cosine h plus cosine x sine h. Split that into the sum of 2 fractions. Then factor sine of x from the first fraction and cosine of x from the second fraction. And rewrite those products as separate limits. At this time, you only know how to find the second and fourth limits graphically. You'll learn how to find them using calculus in a later unit. Using graphs, we can see that the limit as h approaches 0 of cosine h minus 1 over h is 0, and the limit of sine h over h is 1. Substituting these values makes our final answer cosine of x. Thus, the derivative of sine of x is cosine x. Now graph y equals cosine x and its derivative using the n-deriv function on your calculator. If you followed along with example 1 on your calculator, all you should have to do is move the cursor over sine in both places in your y equals screen and type cosine right over them. The cosine graph is the one that's symmetrical over the y-axis. The other graph is a shifted version of it, so it might be y equals sine of x. However, y equals sine of x would increase from x equals 0 to pi over 2. This graph decreases instead. What do you think the derivative of cosine of x is? If you guessed y equals negative sine of x, then you were right. Now we're going to use the quotient rule to find a formula for the derivative of the tangent of x. First, let's write tangent as a quotient. To use the quotient rule, we'll need the formulas for the derivatives of sine and cosine. Filling into the quotient rule, we get cosine times cosine minus sine times negative sine over cosine squared. Our numerator simplifies to cosine squared plus sine squared, which is 1. And 1 over cosine squared is secant squared. So the derivative of tangent is secant squared. Since we just used one of the Pythagorean identities, sine squared plus cosine squared equals 1, in that last derivation, let's take a moment to look at the other identities in that group. They'll come up from time to time in our work this year. The first Pythagorean identity, sine squared plus cosine squared equals 1, is an application of the Pythagorean theorem to a right triangle drawn with the radius of a unit circle as its hypotenuse. If we divide through by cosine squared, sine squared over cosine squared is tangent squared, cosine squared over itself is 1, and 1 over cosine squared is secant squared. So the second Pythagorean identity says that tangent squared plus 1 equals secant squared. If we divide the first identity through by sine squared instead, we get 1 plus cotangent squared equals cosecant squared. You should be familiar and comfortable with these identities, but I recommend that you only memorize the first one about sine and cosine and know how to derive the others by dividing through by sine squared or cosine squared. You can use the quotient rule to derive formulas for the other 3 trig functions, and you may be asked to do so as homework exercises. Here, all 6 formulas together are on one screen. You will need to memorize these. That won't be as difficult as it seems now because you'll use them often. To help you remember these, let's analyze some patterns in the formulas. First, notice that I've arranged these so that sine, cosine, and tangent are lined up across from their reciprocals. If you look at the derivatives, first going down the first column and then down the second column, you should notice that the signs alternate. That's SIGN sign, not SINE. So one pattern you should remember is that these 6 derivatives alternate between positive and negative. Another pattern you should notice is that sine and cosine are paired together in a Pythagorean identity, and they appear in each other's derivatives. The same is true about tangent and secant, and about cotangent and cosecant. Here's a question that requires you to apply some of what you've learned. This would be a no calculator question, so graphing would not be a viable option here. Matching this limit to the limit definition of a derivative, this limit must describe the derivative of tangent of x calculated at x equals pi over 4. You now know that the derivative of tangent x is secant squared. Secant of pi over 4 is the reciprocal of root 2 over 2. So 2 over root 2. And then squaring this gives us 4 over 2, which is 2. So the correct answer must be A. This concludes our lesson on section 3.5, derivatives of trig functions.